So few words about this class. I guess you have all read what are the goals of this course. So basically to get familiarized with algorithms. You might have seen the grading, so you can get fail or pass for the labs. And on the exam, you will have the full range of the grades. Homeworks don't influence your grade, so homeworks are just for you to practice. So that's the grading. We do not have any textbook for this course. There are many books on algorithms, a lot of material on algorithms, but they are either written for computer scientists, so people who do nothing but algorithms, or kind of really the beginner's guide, and they do not really connect to any kind of logistic problems and any kind of logistic algorithms. So we couldn't really find a book which would suit perfectly this course, so there is no textbook. But lectures are self-contained, and if necessary, I can point you to some material to read. So what we want to look at in this set of slides is, well, some generic understanding of what an algorithm, and maybe have an example of an algorithm, and also familiarize ourselves with something called pseudocode, which is a way of writing algorithms. And we will have an example of an algorithm for which we'll have a pseudocode and work it out, implement our first algorithm. And then we will look at, yes, at different problems and algorithms for those problems. So a couple of generic words. What are algorithms? I'm sure you've heard the word algorithms before, used in different contexts. And well, maybe you can get some understanding of what an algorithm is. I will not try to give a definition of an algorithm, but some examples of algorithms. Well, if you cook something, you have to follow certain steps. So you have to follow a certain algorithm. If you play music, well, you have to follow the algorithm, hit certain notes at certain times. Different manuals for assembling things. Well, they also give you an algorithm for assembling things. And here is one website which really puts this idea of manuals into the algorithmic context. So this is just for fun, but you can probably guess that this website, done by our colleagues in Germany, they're kind of mimicking one of the Swedish giants, and the instructions for assembling furniture. And yeah, there are different algorithms, like how do you do sorting? And what they're trying to do here, with a certain degree of success, they try to do it without any text. So just by pictures, some decisions that you have to make and so on. So unfortunately, at least last time I checked, none of the algorithms that we cover in this course has the algorithm in here, but nevertheless, you can look at them. We will be talking about graph algorithms, and this is the one-stroke draw. How can you draw a graph going by all the edges only once? And that's just for fun. But again, an example of the algorithm is a manual for operating something or instructions for assembly. The name algorithm derives from the name of Al-Khwarizmi. And here I give a picture of a corridor in Linkoping University, on Linkoping campus at IDA, computer science department. They have different corridors devoted to different computer scientists. Well, I mean, Al-Khwarizmi was not computer scientist, probably because there was no computers at the time. And well, at the time, people were jacks of all trades, mathematician, astronomer, physicist, and what's not. Anyway, so this is where the name comes from. You can find lots of definitions of algorithm. Even BBC has a definition. Algorithm is a list of rules to follow to solve a problem. And what we want to understand is, what is a problem? So what kind of problems do algorithms solve? And what does it mean to solve a problem? What would be a solution to a problem? So let's look at the first example of a problem, which is, well, an algorithmic problem. Finding greatest common divisor of two integers. So you have two integers, a and b, and you want to find the greatest common divisor, which is the largest integer that divides both a and b. But what we will do now, we will study the algorithm for finding the greatest common divisor. And in particular, we will be able to find the greatest common divisor for any two numbers. So hopefully we'll be able to answer questions 2, 3, and 4 after learning the algorithm for finding the greatest common divisor for any numbers a and b. So just to show you the difference between the possible ways of stating the problem, you may ask yourself this question, like this question number 1: what is the greatest common divisor of two given numbers, like 252 and 105? And the answer would be, well, some number that divides this and this. But what we really want in this course, we want an algorithm that would give you the answer, find the greatest common divisor for arbitrary numbers a and b. Okay, so the answer to question 1 will be, well, a single number. The answer to question 2 is an algorithm. So in the algorithm, we would have to have some input, in this case, 2 integers, and some output, in this case, also some integer. And an algorithm should give you the general recipe, the general way for finding the output from the input. Not for any specific values of the input, but for any values of the input, like in this case, for any values of a and b. So this would be an instance of the problem, but the generic problem is finding the greatest common divisor of two numbers, whatever those numbers are. Okay. And yes, here is an XKCD cartoon. Somebody is asking the algorithmist, could you pass the salt? And well, the algorithmist is not doing anything. And why are you not doing anything? Well, I'm preparing an algorithm to pass arbitrary condiments. And then yes, for a specific instance of passing a salt, you would just apply this generic algorithm. So algorithms are really dealing with generic problems, generic inputs. They have to give you the output for any kind of input, not just for some specific inputs. So yes, yet another definition of an algorithm, systematic method that gives you the output given the input. And then there are some properties. Well, I would say they're pretty obvious. Maybe in 1968, you really had to think out these properties of the algorithm. But now when we study algorithms and algorithms kind of firmly are in our lives, I guess we understand that the algorithm should terminate in a finite number of steps, should give definite answer, and so on and so forth. So I'm not going into many details of these properties. Okay, so here is our first algorithm. It is the algorithm for finding the greatest common divisor of two numbers. And here are the two ways of describing this algorithm called Euclid's algorithm. So one is just, in plain English, you keep subtracting the smaller number from the larger number. And here is the description of this algorithm in something which is called pseudocode. So this pseudocode description is something that we will mostly have for our algorithms. The pseudocode has to give the name of the algorithm. It has to specify the input and has to specify the output. And then it should give you the instructions that you can follow in order to get the result. Okay, so this description on top, which is kind of more human readable or in plain English, may be easier for simple algorithms like Euclid's algorithm. But if you're going to do more complicated algorithms, and we will do more complicated algorithms than this in this course, well, then If you hope that this is the most complicated algorithm you're going to see, sorry, that's the simplest one. For more complicated algorithms, writing the algorithm like this in terms of the pseudocode is more appropriate. But anyway, one way or another, either from this description or from this description, we can execute the algorithm for some numbers. And well, let's take two arbitrary numbers, maybe like 63 and 15. And let's try to find the greatest common divisor of these two numbers, 63 and 15. So follow the algorithm. We have two numbers. One of them is larger than the other. So 63 is larger than 15. So what do? We replace the larger number with the difference between the larger and the smaller. So the smaller number remains as is, and the larger number is replaced by the difference, 63 minus 15, which is, I guess, 48. Okay, so we look at two numbers, and the smaller number remains the same, and the larger of the two numbers gets replaced by the difference. Again, you can see it either from this description or from this pseudocode. So if A is larger than B, then you replace in A with the difference. If B is larger than A, then you replace in B with the difference between the numbers. Okay, so we are here. This is our current state of the algorithm. 48 is larger than 15. So the smaller number remains as is, and we replace the larger number with the difference between the two numbers, which in this case is 33. Okay, and we keep going. So again, we have two numbers. One is larger than another. So the smaller number remains as it was, and the larger number is replaced by the difference between the two numbers. Yes, it's 18. 18 is still larger than 15, so 15 stays, and 18 gets replaced with the difference, 18 minus 15. And now the second number is larger, so the smaller number stays as is, and the larger number gets replaced by the difference between the two numbers, so it's 12. Now this is larger, this stays as is, and this number gets replaced by the difference, 12 minus 3. This is larger, this stays as is. 6 is the difference between 9 and 3. This is still larger, and I guess I just have enough space to finish the algorithm. We replace the larger number with the difference between the two numbers, which is 3. And when the two numbers equal, when we are in this while loop and A is not equal to B, no, right now A is equal to B, or we go out of the while loop and return the answer. Our answer is 3. Okay, so that's how Euclid's algorithm works, but maybe the main idea here is, well, not really to understand how the Euclid's algorithm works, but in general to understand how algorithms work, how to follow the description of the algorithm, and understand what the algorithm is doing. So any questions on this particular example? Now for practice, let's do another example of Euclid's algorithm. And what I will do now is I will stop sharing this screen and we'll start sharing another screen where I have the lectures, I mean the slides, but also the Jamboard. So here at the top, I have the same set of slides, and I will get to Euclid's algorithm, to the same slide where we were before. But here at the bottom, I have the Jamboard where I can write persistent nodes. And again, if the view on on your Zoom screen is too small, don't worry. This is why I have the lectures, or the link to the lectures on the web page, and I have the link to the Jamboard on the web page. So you can just open both the Jamboard and the lecture slides in some other app. In fact, I see that, well, you probably also see that some people are joining the Jamboard. That's fine. And you will be able to follow what's going on. So I'm starting to write on the Jamboard. For some reason, nothing is showing up. Okay, so please bear with me. I'm trying to test. Okay, now it works. Yes, so I started writing. So we are working on Euclid's algorithm. Again, taking some numbers. What was the example? 252 and 105, I guess, over here. Yes. So 252 and 105. Let's find the greatest common divisor of these two numbers. Again, we look at the number which is larger, and the smaller number stays the same. Over here in the slides, I'll put up the description of the algorithm in case you forget. And we replace the larger number with the difference between the two. And let's do the arithmetic correctly. I guess the answer will be 147, right? 252 minus 100, 152 minus 5, 147. So 147 is still larger than 105. So we keep the larger number, and so sorry, we keep the small number and replace the larger number with the difference between the two, and it's 42. Now the number on the right is larger, so we keep the smaller number and replace the larger number with the difference between the two. This is still larger, so we keep this and replace this with the difference. Now this is larger, so we keep this and replace this with the difference. Now they're equal, so the greatest common divisor of these two numbers, is 21. Well, as we had here in our slides. Okay, so we have about 13 minutes remaining in this lecture, and what I would encourage you to do is to run Euclid's algorithm on any two numbers that you come up with, and well, again, give me the answers in the chat. So this was Euclid's algorithm, in particular written in terms of the pseudocode. So some general comments or things about pseudocode. So it's really meant for human reading. It's not for computers. It's just a good way to show the people how the algorithms work. So it's not really a programming language. And in fact, programming languages, well, they go in and out of fashion. Whatever, Python is probably now the favorite. MATLAB is always there. But pseudocode is always kind of with us. So it should be more easily understood than the actual code. You don't have to really adhere to any kind of syntax. All you want is that the pseudocode captures all the essentials of the algorithm. So the important parts are what are the input and output of the algorithm, what the algorithm does, and how it does things. And it helps with manual execution of the algorithms and also with analyzing the algorithms. So a lot of things are allowed in an algorithm. I mean, it has to include the name, the input, and the output. The name may be followed, by the input to show that this is the algorithm that takes certain things as the input. It should most likely use some loops, while loops, for loops, or other kinds of loops, just like the usual programming languages. You can use bold and italic and indentation and what's not. to emphasize things, in particular to show where the loop starts and ends. Doesn't matter what you use for the assignment, this colon equal, just equal, or this arrow. If you want, you can go, MATLAB style and use semicolons to end the rows, but you don't have to do that. When you're indexing arrays or matrices, well, you can use square brackets or parentheses, doesn't matter. If you want to indicate a range of values, again, use anything you want, semicolon or just 3 dots. Any words which are kind of understandable, they are fine. Repeat, until, if, and if, whatever. You can also refer to other algorithms. So again, here is the Euclid algorithm as an example of a pseudocode. We will have many more algorithms and pseudocodes in this course. And the last slide in this lecture is a kind of preparation for the next lecture that we will start after the break. Here is an example of a very important problem, the shortest path. So you have n cities and there are roads between them, and you know the distances between the different cities, and you want to find the shortest path from some starting city to, well, maybe all cities in your network. So there are various ways in which you can solve this problem. In particular, you can go through all possible permutations of the nodes, like you start from this one, go to this, go to this, go to this, go to this, and so on, or maybe go to this, then to this. So try all possible permutations, but there are too many possible paths, too many permutations. In fact, it has its own notation n factorial, and this number grows, n factorial, the number of possible paths, grows very fast with the number of nodes in the network. And we want an efficient algorithm that will give you answer even on large networks, and this is the algorithm that we will study